from a manufacturing perspective, can you get into some of the mechanics around why is it so challenging to make a mask to
Yeah.
prevent this?
Well, so what's happening because so many people are getting sick, there's this huge increase in demand for a very specific set of things: masks, ventilators, things of that nature. These are not, and these are things that are really hard to just make in your basement or garage. And since the demand has shot up, there's so many people who want to help, who want to make this stuff. People are sewing masks. People are trying to come up with garage ventilator designs, and it's fantastic. It's great to see everyone trying to help. But certainly there are realistic issues with, with how hard these things are to make. And, to think about that a little bit, if you have a garage ventilator, typically when you make a medical device, that is years of development go into it, years of engineering and research and testing. And then there's these strict processes that, you have to verify these designs before they make it into operation. And we can remove a lot, the red tape aspects of it, but we still need to make sure, if you deliver some new ventilator design into an ICU, you have to be fairly confident that it's going to help more people than it's going to hurt, right? We have lots of people, sewing masks at home, for example, and that's great. And I think there's going to be a use for a lot of those masks, although it might not be doctors in hospitals or patients in hospitals, because, what people are always talking about is you need to have, these N95 masks, right? And the key there is you can breathe through them, but they actually stop the virus. And that's a really challenging thing to make. A cotton piece of fabric isn't going to do that. And why is that? Let's talk about how big these things are.
Yeah.
So viruses are really, really small. The coronavirus is, and I just looked this up, it's 125 nanometers. That's the diameter. It's like a spherical shape.
Okay.
So 125 nanometers, that's very small. People are talking about 3D printing masks. The smallest printable feature, so if you're trying to make something with a hole in it, the smallest you could really conceivably 3D print would be about 0.5 millimeter, 0.5 millimeters.
Okay.
That's 4,000 times bigger than a coronavirus particle.
So when they say that South Korea somebody's invented a 3D printed mask, it really is not going to be sufficient for blocking.
There's stuff we can do with 3D printers. We can print maybe some sort of mechanism that holds the filter fabric in place, or we can make face shields. Like there's a lot we can do with 3D printing, but we're not going to print, a filter paper with the right, size holes in it. Again, to let air through, but not viruses. Now, people can produce stuff like that. So when we think about relative sizes, so that you can 3D print things thousands of times larger than a virus, but we can manufacture in general things much smaller than a virus, which is pretty cool. So current state-of-the-art electronics processes, the kinds of things, Intel would use to make a computer chip, they're down at 5 nanometers. They're making transistors that are about 5 nanometers. So several times smaller than a virus particle. So it can be done.
The general manufacturing. So you're saying, okay, we have this class of manufacturing that's been hot for 3D printing.
Mm-hmm.
And then we have kind of general traditional manufacturing of electronics equipment, sort of a traditional manner. We can get down super small there. Is there anything in between 3D printing and full traditional manufacturing? Is there you had mentioned CNC. Is that a different type of manufacturing that slots in the middle?
Well, you can do different stuff with CNC. A lot of this will come down to, just the right materials exist. Like, can you find a material that maybe is natural or is easily made through, I guess my point is we're not going to be cutting holes of this size.
Yeah, right.
But we may be able to find some materials that work.